I've been told that the way to make these things interesting, you got to throw things in here. Like ask little questions or throw in quizzes or something like that. But I'm not ready to do that. I just want to record what I'm going to talk about in class today. So we're gonna finish off chapter 26, the whole thing with chi-square. So let's just take a second and review where we've been at so far. Okay, we started out, as you can see here at the beginning. Okay, so we got the chi-square, one variable. Would you close the door, please? And you know, we had a bunch of categories for the variable. Okay, we did this for birth, you know, for astrological sign. Okay, astrological sign. So that's our variable, was the sign, and then we had, you know, the 12 categories. And what we did was called a goodness of fit. That is, if we made a null hypothesis that these numbers should be uniformly distributed, were they? Okay? Now, how did each one of these cells, each one of these categories contribute to this statistic to figure this out for a hypothesis test? Well, chi-square equals the actual minus expected, the sum of the actual minus expected squared over the expected. So we did that for each one of these cells where the calculator did it for us. We did it manually if we don't have the thing on our calculator. We got a statistic and based on the degrees of freedom, which was the categories minus 1 equals degrees of freedom. Based on degrees of freedom, then we either had significance or we didn't, just like we do with any other test. Okay? All right. So we did that. Then we proceeded on to, and there's the formula for the chi-square. I'm going to make this a little bit smaller so it's easier to see, so I can see where I'm at. Okay. So then we went on to consider more than one dimension. Okay, so in other words, more than one, same categories, but measured over time. Okay, now what do I mean by that? Okay. All right, so we started out here, we were talking about high school. Okay, and we said, and here's the variable. The variable is, what are they doing after their graduation? So call it post-grad activity is the variable. And then we had 4 categories, going on to college or employment or whatever, military, travel. And then we did the same thing for each cell. We measured the actual minus expected squared over the expected. We added all those up and we decided if we came to significance or not. However, we added something new, okay? And that is what we're going to talk about right now. And we're going to go on to the last category. You know what? Let's leave this for now. We put this in a matrix. We covered all this, right? We put it in a matrix and we just see, you know, the matrix made us the actual and gave us the expected and so on. All right. Now, let's go to the final test. And the final test is similar to the test for homogeneity, but instead involves what's called independence. So let's get to that part. Now, did we actually start talking about independence yet? No. Okay. So, you know how this book is always full of stuff that, you know, that's of pertinent information for high school students. So here we got tattoos. Okay? Now, for the first time, up until now, we were dealing with one variable. With the goodness of fit, we talked about one variable and all of its categories and whether or not what was expected was the same, it matched what we actually got. Okay? Then we took the same thing, one variable, and we saw if it changed over time, and that's the homogeneity. So in other words, did the distribution stay the same over time, or did it change? Okay? Now, for the first time, we're considering 2 variables. Now, if you want to look at this, this is page 619. Namely, whether or not you get hepatitis C versus whether or not you have a tattoo. Okay, now I'm not going to ask any of you if you have tattoos. I made that mistake in another class, and I got all sorts of information that I would really not have. So, suffice it to say, here's the issue. Hepatitis C is fatal and incurable. Now, it can be controlled with drugs. If you get it in the United States or something, chances are it's not going to kill you, but it kills a lot of people around the world. And if you're poor and you get it, you have a big problem. It's probably going to definitely end your life before it should. And it is incurable. Now, this study has to do with the probabilities of getting, of trying to ascertain if there's a connection between getting a tattoo and where you get it and getting hepatitis C. All right? Now, the way we're going to conduct this test is exactly the same as we did the test for homogeneity. You will take these numbers here, 3 rows and 2 columns. You'll put them into matrix A. And you don't need to change anything in your matrices. We'll sit down and we'll do this together, and then we're going to run the test. Okay? Now, let's just run through the preconditions. Okay? I think at some point they tell us that they're random. There's no reason not to assume that all these subjects are independent of each other. They're certainly less than 10% of the population. Now, the one precondition that we have to be worried about is, do we have at least 5 in every cell? Do we expect 5 in every cell? We won't know that until we run the test. Okay? So let's get the calculators out, and let's plug the numbers in. I got to start at my calculator. I think I'm going to pause this for a second. Yes. So I'm going to pause it while I'll keep recording. Just to resume recording there. All right, so I'm going to go to stat. No, not stat. What am I doing? Let me get out of there. Second and inverse. We're going to go to matrix A. So we're going to go to edit, matrix A. Now, my matrices are come up initialized because I just started the program. If you got stuff in there, don't worry about it, okay? And we're going to put in, I need my keyboard now. We're going to put in a 3 by 2 matrix, 3 rows by 2 columns. So 3 by 2, and let's put in the number 17, 35. Make sure the zeros match the layout of your matrix, 5322 and 491. Okay, let's double check. 17822 is column 1, 3553, 491 is column 2. Okay, now I'm going to get out of here. So I'm going to do a second and then second and then mode. Okay, and I'm going to run the test. So I'm going to do stat and go to tests and arrow down to chi-square test. The chi-square homogeneity test and the chi-square test for independence, which is what this is called, are the same test. Okay, because you're going to establish a chi-square statistic for every cell. So we got A, B, and then calculate. Okay, did we already do this? Okay, so everybody is doing this right now? You doing this? You already done? Okay, you guys are so fast. All right, so we got a big, huge, fat chi-square statistic, especially for the degrees of freedom are 2. Now, why is the degrees of freedom 2? David, nice and loud. Answer real loud so we can hear you on the microphone here. The degrees of freedom are 2 because
there is 3 rows.
Okay, 3 rows.
So you do 3 minus 1 and then multiply by the columns minus 1, which would be 2 minus 1.
Perfect. Okay, 2 times 1. All right, nice going. All right, everybody catch that? It's rows minus 1 times columns minus 1. Okay, so what would be the null hypothesis, Alex? Nice and loud. The null hypothesis.
The null hypothesis is the tattoo parlor hepatitis
Okay, you don't know. That's all right. Maddie, null hypothesis. You're skeptical. What's your null hypothesis?
So that,
You're one of these scientists, they have lots of tattoos, and you're very skeptical.
so that people would, or having a tattoo doesn't make you more prone to having hepatitis.
Okay, that's basically. No connection between hepatitis C and a tattoo. All right? Alternative hypothesis. Alex, nice and loud.
Having a tattoo does make you prone to having hepatitis.
Okay, there is a connection. There is a connection. Okay, that's what Peter was going to say. He's waving his hand, right? Okay. All right. It's real simple with the chi-square thing. There is a connection, there is not a connection. Okay, and there's no symbols involved, so you don't have to worry about all those letters, all that tiresome stuff. Okay, conclusion. Michelle, nice and loud. Come up to the speaker. Come on. Come on, let's go. The conclusion. First words out of your mouth. We do what? Reject or not reject?
We reject the null hypothesis, or we fail to reject the null hypothesis.
We fail to reject?
No.
Okay, Sydney, what do you say?
We
reject what Michelle says.
wait, so if it's a p-value.
The P is small.
So we reject the null hypothesis.
Okay, we reject the null hypothesis. Continue. Kelly, nice and loud. Yell.
There is no evidence that there's a connection between tattoos and hepatitis C. There is evidence.
Which is it, Kelly? Are you going to go get a tattoo, or are you not going to go get a tattoo right after class?
No, there is evidence that there's a connection between tattoos and hepatitis C.
Okay, all right. All right, now,
Wait, is this in the parlor or not in the parlor?
okay,
Everything.
ask that question again nice and loud.
Is this in the parlor or
Is that
elsewhere?
the loudest you can say?
We said it like 4 times right
Is
now.
it-
Christine watched the video and be like, what the?
Louder.
Is this in the tattoo parlor or elsewhere?
Who wants to know? Raise your hand if you want to know.
I know.
Okay, let's do a count. Ed, do a count. How many got their hands up?
Come on, everybody.
What you want to know?
There you go. Raise them high.
Everybody wants to know. Everybody wants to know. Okay. All right. Gee, I wonder how we could do that. Well, I'm going to show you how to do that right now.
Okay. All right.
Alex, you are so great. She's leading me right into the next part of the lesson.
Just helping you out.
So, live for others. That's Alex's motto.
Hey, John.
Okay. All right. So here's what you're going to do. There's a statistic that tells you it's comparable to a z-score, how much each cell contributes to the chi-square score. Manny, you writing this down? Manny, what are you working on? Yeah, you are. Yes, you are. I can tell. She's a multitasker. You know those commercials? See the commercial they have on sports all the time? Is it better to do one thing at once?
Oh, the little girl.
Yeah, that's Manny. Yeah, I want to work on science, and I'm doing. What else you do? Religion. So, okay. Here's the standardized. This is called the standardized STANDARDIZED residual. Okay. Now, a standardized residual means you're going to take that residual and you kind of turn it into a z-score, sort of comparable to a z-score. So, if you take actual minus expected and divided by the expected squared, I'm sorry, the square root of the expected. Okay, actual minus expected divided by the square root of the expected, you will have the standardized residual, S, call it SR, okay, and that will tell you the statistical meaning of each cell, how much it really contributes to the chi-square statistic. Because this number here, this is the square root. This is the square root of the chi-square. Okay? All right, so how are we going to do that? The calculator won't do it for us. Okay? So here's what I'm going to show you how to do. You got to pay close attention. Okay? Now, in order to do this, let's take a look at. First, we have to look at matrix. I'm going to take some pictures. So I'm going to do second and inverse, and I'm going to take a look at matrix A. So here's matrix A. I'm going to take a picture of it. Okay? matrix A. That's the actual. Now let's look at matrix B. So second and inverse, and arrow over to edit, and matrix B, here's 2. Now, these are the expecteds. Now, do we have a problem here?
Less than 5.
Yeah, one of them's less than 5. One of them's only about 4.
Two of them are.
Hmm?
Two of them.
Yeah, and then the other one's 4.5. Okay? So we got to make note of that, whether or not we're going to use these numbers. Okay? Now, but we're still going to go ahead and work with this stuff anyway. Okay? So let me take a picture of this. Okay? So here we got, let me make this a little narrower. Alright, so here's the actual and here's the expected. Okay? Now, let's remember what our statistic is. Alright? The standardized residual is actual minus expected divided by the expected squared. Now, let's do actual minus expected on the calculator. Namely, use the matrices. So, we're going to take A minus B and store it in C. Alright, so let's do that. If you haven't done it already, let's do it now. So I'm going to do second inverse, God bless you. A minus second inverse B 2. Okay, and I'm going to store it in matrix C. Second inverse 3 for C. Okay? A minus B and store it in C. Now let me write that down here. This is the calculator procedure we're doing here. Okay? So, A, call it matrix A, minus matrix B, and we'll store it in matrix C. Okay? Alright. Now, here's what we're going to do. I cannot take matrix C and divide it by the square root of matrix B. The calculator will not let me do that. Now, if you ran this test on Excel, or if you did it on some kind of software you had on your phone or on your iPad or something like that, you would get these standardized residuals, I am sure. Okay, but I'm going to show you how to do it on the calculator. Now, here's what we're going to do. We're going to take matrix B, the expected, okay? We're going to take B and we're going to store it in 2 lists, L1 and L2. Now there's a command for doing that, okay? So we'll have matrix B in L1 and L2. So let's do that right now. So we'll take okay. And then we're going to take matrix C and we're going to store that in L3 and L4. Okay, so we'll have in matrix in L1 and L2 will be the expected. In L3 and L4 will be the matrix of actual minus expected. Then we'll take L3 and we'll divide it by the square root of L1. And we will take L4 and divide it by the square root of L2. And that will give us the standardized residuals for this test. Okay, you guys following me? Let me put L3 up here. Let me show you what we're going to be doing. Let me show you. I don't need this anymore. Let me put L3 up here. So I want everybody to understand what we're doing before we do it. Otherwise, there's no point in doing it. So I'm going to go second and inverse and arrow over to edit. And oh, I didn't execute the command, did I? I didn't do it. Okay, second inverse 1 minus second inverse 2 store second inverse 3. Okay, and I hit enter. Alright, now I'm going to go to, I'm going to clear this and do second and inverse, arrow over to edit, and I'm going to take a picture of matrix C 3. Alright. Okay. So, going to take matrix C is going to be an L3 and L4. So I'll take L3 and divide it by the expected for the same one. Now, you can look at this and you can already see that some of these the z-scores are going to be really big. But we'll run this exercise and you'll see what I'm talking about. So let me clear the screen. So we're going to hit second and then stat, and that puts us in the list menu. We go to ops and arrow down to matrix to list. Matrix to list, hit enter. And I already wrote down here what we're going to do. So I'm going to do second inverse matrix B number 2 comma L1 comma L2 close parenthesis. Now the reason why I wrote this out ahead of time so I can keep straight what I'm doing, because right now I'm in the middle of a bunch of alphabet soup. Okay? Alright, so let me do this. I'm going to hit enter. Now, let's look at L1 and L2. Okay? There's matrix B right there. Let me take a picture of that. Okay, there's L1 and L2. Alright, so that's looking good. Alright, now I'm going to get out of here and I'm going to do matrix C and L3 and L4. So second, second and stat into the list menu over to ops, matrix to list. Enter, and I'm going to do matrix C, second, inverse, 3, comma, L3, comma, L4. Alright, now let's look at, clear this, and let's look at L3 and L4. And there's, okay, there's matrix C, okay? Alright, so now we're all set. So, I'm going to go to L3. I'm going to go to the top. I'm going to say L3 divide by the square root of L1. Enter. Okay, I go to L4, go up to the top. L4 divide by the square root of L2. Alright, now in L3 and L4 are what effectively is the z-score of each cell. Okay, so let's take a picture of this. And let me make this, for a second, and let's pull this over. Okay, here's the thing that, so here's L3 and L4, and I'm going to make this bigger. Okay, now let's talk about L3. Okay, now here's the numbers we need to get rid of all this other stuff. Okay. All right. Now, oh, and here's what I want. Let's do this. Let's look at the original data. Okay? All right. So what does this number here mean? Okay, this is got hepatitis C, went to a tattoo parlor. Okay? That number, that 6.6 means you are way more likely to get hepatitis C from a tattoo parlor than in any of these other cells. In other words, think of this like standard deviations. Okay? This is 6 standard deviations from the mean. This is way, way off the mean. So in other words, if there were more is happening is 6 standard deviations from the mean. Sorry. Okay? So, in other words, very unlikely would happen unless there is what, Alex?
Oh, I'm just something else.
Okay, go. What? What's your question?
Well, I'm just thinking, like, if you go to a parlor that's like nice and sanitized and clean,
Just
like
like
a guy's like
Okay, now
professional.
look, I don't know, things have changed a lot since this book was written.
Oh yeah,
Okay, it's like 10 years old.
compared to like Bob's face.
Sketch guys basically.
Yeah. Like some,
Or-
I'm not an expert. I'm not.
So, all I'm telling you is, I'll tell you 2 things about this, okay? First of all, this, these numbers at some point were real. They don't make up numbers, the stuff that's in this book. It's based on real research. But it would be a good thing to find out what it is currently. You know, get some data that's current. Okay? But the other question, well, we're going to ask another question now, which we can generalize to, which is just what is the connection between getting a tattoo in general and getting hepatitis C? Forget about where you get it.
Oh, the type of person that they are?
No.
Oh, like
No. Getting a tattoo or not getting a tattoo. Okay, let's suppose we eliminate the, suppose we combine this data here. Okay, just tattoo yes and tattoo no. Make it yes or no. Okay? The main thing though, what we're trying to, let's forget the whole thing about whether tattoos are good or bad. Okay? One thing I do want you to be aware of though, is that there is erasable ink. I'm not talking about, you know, the little tattoos you got with the bubble gum card with your little kids or something or what. I'm talking about tattoos that don't wash off or something. They are quote unquote permanent, but they can be erased. They're made with some kind of ink that can be removed painlessly with a laser. I mean, if you're into getting tattoos, you should know about this. Okay? Or if you consider it in the future, look into it. But let's forget about the whole thing of saying tattoos are good or bad or whatever. You know, they are what they are. And, you know, whether you get one or not. But let's figure out what each one of these numbers is telling us about each one of these cells. That's what I want you to take away from this. Okay? So, the cell with the 6.62 is telling us that, you know, if you consider this to be a z-score, then the probability that that you would get this many people getting hepatitis C in a tattoo parlor, assuming there's no connection, that's the probability of that happening is 6 standard deviations away from the mean. You got to think about it like that. Okay? In other words, that's a really low probability. Okay, 6 sigmas, we're talking like 1 in a million. Okay, or 1 in 10 million. Okay? Now, what about the probability of no hepatitis? In other words, you got a tattoo, that's what, look at this number here. Okay, you got a tattoo in a tattoo parlor, what's the probability you don't get hepatitis? Okay, the incidence of no hepatitis is almost 2 standard deviations to the left in the negative direction. Okay, so in other words, the incidence of not getting hepatitis C and going to a tattoo parlor has a negative, the z-score is negative. In other words, you should be more likely to not get hepatitis C if you were, you know, if there's no connection between them. So if there were no connection, you shouldn't be getting hepatitis. There should be more of a likelihood that you're not getting hepatitis C. So that's what this negative number means here. Okay, same thing for hepatitis, you know, look at the connection between tattoo elsewhere and hepatitis C. It's 1.6. Okay, what is that? If you were putting this on the normal curve, that'd be around 95%, right? If you do a one-tailed test, or 90%. Okay, so still, you know, unlikely if you're assuming there's no connection. And then you go to the other side, what's the likelihood of not getting hepatitis C? Well, if you got a head tattoo somewhere else, now you still have a negative correlation, almost negative half a z-score. Okay? Now, hepatitis C, all right, we'll look at that, negative 2.6. Okay, if there were no connection, there's no connection between hepatitis C and getting a tattoo, then not getting one and not getting hepatitis C is more negative than it should be. Okay, that's a vote in favor of a tattoo in terms of hepatitis C. And I'm sure you're correct and things are much better now than they used to be. Okay? But it's just something to keep in mind. And then finally, no hepatitis C and no tattoo. Okay, positive connection between them. All right, so this is, sorry I said anything bad about getting tattoos, those of you that have them. Okay? There's nothing moral about it. You know, it's not a moral decision. Okay? Well, maybe it is, maybe it isn't. I don't know. You get a picture of Jesus or something like that. It's a matter of having information and about your own safety and avoiding disease. Plus, you know, and there is a morality to it if you think about, do you want to remain somebody who can donate blood? You know,
6 months later.
6 months? You sure? Yeah.
Well, like here it's like a year, but other places it's 6 months.
Here it's a year, unless you have hepatitis C.
Unless I have
Then you can never donate blood.
Yeah.
So, okay? I don't know. Well, if you donate blood, right, they'll test your blood, and I think they'll tell you.
Tell you the matter.
I think they'll tell you. I don't know. So, yeah, don't have to bother showing up again. Not that we expect you to. Okay, so this is how you analyze the cells in either a test for homogeneity or a test for independence. Okay? Now here's what I'd like. Any questions about this procedure? Yeah.
Wait, so the problem is not over after you think the conclusion you selected you.
Well, the book doesn't make you do this. But here's what is going to come up on a test. Suppose this was on an AP exam. Or, let me put it to you this way. Okay? What was the first thing that naturally occurred to you? It was Alex's question, right? Well, all right, we got this table, and we just answered this very basic question of there being a connection or not being a connection. But you would really like to be able to differentiate your conclusion much better. So, at the very least, you would need to be able to do this on at least a cell-by-cell basis. In other words, not do every cell manually or something like that. I don't think anybody would ask you to do that. But suppose somebody said, okay, we're running a chi-square test of independence on this information. You know, write your hypotheses, write your conclusions. You state your chi-square statistic, et cetera, and then they might ask you as a follow-up question, what is these, you know, they might ask you about the standardized residual from one of these cells, and to analyze, you know, what's its contribution to the chi-square statistic. How unusual are these results, assuming that the truth of the null hypothesis. So, this exercise, I feel, is a good way to do all of them at the same time. So for your own, if you want to do analysis yourself, but also to get into your head what a standardized residual is, as opposed to just knowing the chi-square statistic for each cell. That's useful, but the standardized residual is better. Okay?